Okay, this is the lesson on applications of algebra, where we're going to go over the swimming pool example once again. This is something you will need to be able to do for our problem solving or our application task, which will be on Friday. Okay, so you need to make sure you go over this and make sure you understand it. Okay, so the idea is, in this example, we want to come up with a way of quickly working out how much we need to charge a client who wants us to build a path around a swimming pool. And this client, they're a bit finicky, they change their mind all the time, and so rather than have to remeasure and recalculate every time, we want to come up with a way of doing it really quickly. And algebra, we can use algebra to help us do that. So that's what this lesson's about, and that's how it will relate to our problem solving activity on Friday. So anyway, let's start. So we're dealing with a swimming pool which actually has a length of 18 metres and a width of 7 metres. And the idea is that this swimming pool is going to have a path around the edge of the swimming pool. And we want to be able to quote based on however wide that path is. Now we're assuming the path will be the same thickness or the same width all the way around the swimming pool. And because we might want to change that value, we're going to use the value x for that. We're going to use some algebra. So that's called a pronumeral. And we're going to use the pronumeral x to represent the width of the path. And the idea is that if we want to do a quote and the client said, we want to work out how much it would cost us to make a path that's 1.72 metres wide, well then we could simply plug it into our quick formula that we've created and we'd be able to spit out the answer really quickly. So that's the whole idea of this. So having a look how we do this, here's our swimming pool, and this is just the pool itself, the water, and you'll notice that I've marked in the length of the pool, which is 18 metres, and the width of the pool is 7 metres. And around that pool we've got a path, and what we're saying is that distance, the width of that path is x meters. So that distance there is x from the width of the path. Now the path's width is going to be the same all the way around it, so that's also x meters, and that width over here will be x meters, and of course this width over here will be x as well. So the width of the path is the same all the way around the path. So in order to quote correctly, that's what we want to do. We want to come up with a way of quoting the exact number, the exact amount to construct that path. In order to do that, we need to work out the area of the path. That's what's really important here. We want to work out the area of the path. Not the area of the swimming pool, but the area of the path. In other words, we want the area of this region around here like this. That's the area we want. So we need to come up with a way of finding out or working out what that area is. Now, you might actually realize that the area of that path is actually the big area of the big rectangle. This big rectangle take away the area of the small rectangle. In the same way that if we had a circle and we cut a hole in the middle of the circle, then the area we have out here, the area of the donut if you like, would be the area of the big circle take away the area of the hole, and that will leave us with the area around the outside. So that's pretty much what we're going to do here as well. We're going to work out an expression for the area of the big rectangle, and then work out an expression for the area of the pool itself, just the water. And if we take away the area of the water from the area of the big rectangle, that should leave us with the area of the path. Okay, so let's work out the area of an expression for the area of the big rectangle. So the large rectangle. We want to work out an expression, an algebraic expression for its area. The reason why we can't work it out exactly is because we don't know that exact length. We know it's going to be from there to there, that length is going to be 18 meters, but we don't know this bit here. We just know that that's x. So that's the clue of how we're going to do this. We know that the length of the pool, the length of the big rectangle, the large rectangle, is going to be 18 meters from there to there. That's 18 meters. But we know that from here to here, we know that that's x meters. So that bit there is x. Likewise, on this side, we know that this bit here, this extra bit, is also x because they're the same. Now, can you come up with an expression for that full length? Pause the video and then start again once you've had a go at it. Okay, welcome back, and hopefully you worked out that the length of this large rectangle is going to be 18 plus x again. So that length, the length of this large rectangle will be 18 plus 2 lots of x. Now, just an aside, remember we said that the area of a rectangle, the area of any rectangle, is its length by its width. Equals length times width. So the area, so the length of our rectangle, we've just said is 18 plus 2x. Let's do the same thing for the width of the large rectangle, this section here. And I'm going to stop the video now, and to continue you'll go to video, the applications of algebra, video 2. Thank you.